Okay, this is better. This is better, right? Hello. Hello, young mogul. Sorry, it says message retracted. I don't know what that means. And also, hello, Asitsu. Sound again, yes. So this time completely my fault, and I knew what it was, and I forgot. So I started the stream, and then my one of my ex bosses, well, I guess he's also a current boss. He's both ex and current boss. Called me up and he wanted to chat a little bit. So I didn't want to accidentally leak that on stream, so I double muted myself, and then I only one unmuted. So yay. All right. So how are you all doing today? I've got some nice green afternoon tea, and we are ready to check out some coding game. So I've done a few of these. And I've never really tried too much of it. It says that I'd show up here as a Twitch streamer if I put coding game in the title, and I think that that didn't work because I didn't spell it correctly with the correct capitalization. So hold on, let me try that. Let's switch to coding game with capital C and G, and maybe now I'll show up. Okay, eventually, maybe. But all right. So, oh, it may take a few minutes. Okay, perfect. So, the reason why we're doing this. Oh, and thank you, Young. Yeah, thank you. So anyways, why are we doing this instead of Axum? So I explained this morning. We're doing this because Axum is doing a lot of updates. Hey, there I am. Also, I still have, I have a black screen. Well, I'm glad that's showing up. I tested right before I went to the starting Zoom screen, and it didn't update. Oh man. Okay. So I have to do this thing at the beginning of every stream. I have to right now unplug and replug in my Elgato capture device. And then I can, in OBS, deactivate and reactivate it. That seems to be what I need to do. There we go. Okay. All right. So, Zilby's not here. We don't need to look at his bed. But okay, back to the explanation. So what happened to Axum? It's on hold right now, but that's only because Axum had a big update. It went to 0.17, and it is waiting. Exactly, Axum is making us busy. Yes. So because of the 0.7 update, it broke a lot of things, and it doesn't look like they're going to go straight to 1.0 and then just break a couple more things. It looks like they're going to go to 0.8, maybe 0.9. Who knows how many more updates they have? I'm sure they do, or at least they have an idea of it. And each time is going to be break an update. So instead of writing a course and then redoing the entire course every time there's a little dot update, I'm just going to hold off, and then we're just going to redo the course once we're at 1.0, because that I don't want Axum to be my life for the next 6 months and then have to do it again. I don't know how long it's going to take. So we came up with a plan. Let me see if I can open up what the plan is. We're going to split the morning streams and the afternoon streams. And we're going to be doing, in the morning streams, we're going to be doing some more sort of businessy type things. So we're going to do a 0.7 walkthrough. And so what that means is I'm just going to build an app with it. In this case, we're going to build a little X Twitter clone, something that just takes in the tweets and does some other little things around it. And that's it. That's all we're going to really do with that. So it's not going to be like a full course. It's just going to be like me building something with that. And then we're going to follow that up with the one for U, because U.21 came out, and it apparently has a few barricade changes. And I realized that I probably don't want to do a U full course until that's 1.0 either. And then after those two are done in the morning, we're going to, we have some other apps that we can sort of pull from here, and a bunch of technologies for us to take a look at. And we're we're looking forward to that. Now in the afternoons, we're going to have some fun with that. So we're taking a look at coding game right now. In a couple days, December 1st will roll around and Advent of Code will be available. So we're thinking of taking a look at, an Advent of Code or two, shuttle code hunt a little bit. We might take a look at the Try Hack Me event. And then also take a look at Screeps and then see where Screeps Arena is, because it's been a while for that. And then also potentially some code crafters. I'm not fully sure yet. We'll see how that plays out. I have a message to them because that's more like closed system for like what I can actually show and display on stream. So today is checking out coding game. Oh yeah, I got the same dev environment like you, Alacrity, Helix, and Zealage. Oh yeah, it's a lot of fun. I somehow broke my environment on my day job's computer for Helix. I need to fix it again, but everything works really well on here. I really like it, especially for Rust development. Okay, so coding game. Now I haven't taken a look at coding game in a long time. So what is this? It seems to be that there's a couple things that we can do here. First off, everything has changed. When I used to come here, this first page was really busy and was like one of those almost like elite code type of like just overwhelm you with different options and then like, okay, go jump in and like actually try out a challenge. But it's a challenge web app, website. But their challenges are a little bit different. They're games. And they also have these Clash of Codes, which we could try one eventually today and see how that is. But those are like 5-minute coding battles. Have you ever seen like typing, like Type Racer or something, where people are like typing against each other? Think of it like that, but for coding. I watched a bunch of the ones from CJ when he was doing Coding Garden with Clash of Codes. And those were always fun. So we might try a few of those today. I don't know how Rust will fare in them. I'm a little bit concerned about that, but we have plenty of time. So let's just sort of see what it wants me to do here. Choose a nickname. I have a nickname, right? Yeah. So I've already done a bunch of these apparently. So cool. They have like an entire quest map system. Oh, and an entire map through all the stuff. So they have AI for bot programming, algorithms, and Clash of Code. Oh, and Clash of Code is going to be that 5-minute thing. I kind of like the AI one because that sounds fun. Cool. Okay, so we discovered bot programming. Your first bot. Cool. So this one in progress. Let's take a look. So apparently I started this one off and then I didn't do anything with it. I think I was like just sort of looking at it a long time ago and then I completely forgot about this. I don't know if I did this in Rust or in something else. So we'll take a look at it. So Mad Pod Racing. What will I learn? This puzzle game starts with a step-by-step tutorial that will help you get familiar with Coding Game's multiplayer games. It provides an easy introduction to bot programming through a starship race. The aim of the game is, of course, to win the race against other players. To succeed in this challenge, you will be able to use different mathematical concepts such as trajectory calculation, collisions, speed vector, or inertia. The game is very simple to start. Rules are easy to understand and only requires a few lines of code to move your ship around. However, it has near infinite possibilities of evolution as you can improve your artificial intelligence step by step while sharpening your coding skills. All right, so I mean, eventually all of these things, especially with neural network and multi-agent, is going to be interesting. But I think what it does is it just slowly introduces you to it. All right. This puzzle is divided into 2 distinct parts, from Wood to Silver League. So we're in Wood League right now. A tutorial containing several missions for newcomers to the multiplayer mode with a simple goal. Your program must win the race. You'll unlock new roles at every league, and then just more other stuff. So we don't need to worry about that. And then this is what it looks like. This is literally pod racing. Oh, and there's multiple laps, so we have to like go 1, 2, 3, 4, and then try not to collide with each other too much. Okay, so let's join. I think this is this my code right now? So, okay, this is Rust. All right, so pseudocode algorithm. This is gonna be fun. We're gonna see how it is. A simple algorithm that uses the angle. I've always loved games for programming and learning stuff. I always thought that that's so much better than any other type of lesson type thing. And if I knew how to like make these type of things, this is what my LMS would be. Something like that. A simple algorithm that uses the angle is the following. If the next checkpoint angle, are you actually coming in like this, or is it going to be next underscore checkpoint angle? I bet these is written for like JavaScript or something. Yeah, look at that. If next checkpoint angle is greater than 90, so Tea Kettle Drone, hello, how are you doing today? Or next checkpoint angle is less than negative 90, then set the thrust to nothing. Okay. Otherwise, 100% thrust. So we're either on the gas or on the brake. Wait, oh, no. They said like eventually we're going to get like, so either, yeah, we're either on the gas 100% or we're just no gas whatsoever and we're coasting. Oh, this is Python. That feels like Python to me, but doesn't print in Python require parentheses? I actually don't. I stopped using Python before I learned 3, like a lot of 3. So I don't actually remember. I think this is Python 2, right? Okay, summary of new rules. You can now use distance and angle as an extra input for your AI. So we have our pod orientation, next checkpoint angle from 180, so from negative 180 to 180. Yeah, oh, just pseudocode. Okay. I don't know why I was like, it even said it's pseudocode, but like my mind went to like, this is too real. Like I know languages that look like this. So it just went for that. The function call is like Haskell. Also, hello, Bemaro. How are you doing today? Or how was your day? Because I think I saw you this morning. Okay, next checkpoint angle from, okay, so from negative 180 to 180, next checkpoint distance. Okay, so we get all that. The next checkpoint distance. Okay, the goal, win the race. Rules, the circuit of the race is made up of checkpoints. Okay, so we saw what this was. We must pass through each checkpoint in order and then back to the start and then over again because we have to go through however many laps there are. We have 16,000 units wide and 9,000 units high. That's probably pixels. Yeah, X00 is the top left pixel. The checkpoints are circular with a radius of 600 units, so we don't have to be exactly in the middle, but within 600 of it. The program must, with an infinite loop, read the contextual data from the standard input and provide to the standard output the desired instructions. I'm doing really good. Just sort of like a nice day today of like setting up applications and doing the day job thing. And then here I get to spend time with you playing games, which is awesome. Game input. Input for one game turn. First line, 6 integers, X and Y for your pause position. Now, okay, so let's see what this is too much. I'm getting overwhelmed by all this stuff, and really what I want to do is just take a look at this. So look like we have a macro here. So we have parse input, which is going to give us do you use that automatically here? This is a lot of boilerplate code for us. So we have our main game loop. You're thinking of using your Rust coast as a reference for making your own coast for another topic. Nice. Yeah, no, that's totally cool. I want as many people to learn just stuff as possible and like get into that growth and learning mindset. So I'm okay with that. If you want any helps or tips or anything else, feel free to ask or chat about it on Discord. We can create like we can like do a topic or a thread on education stuff in theory. Okay, so oh, look at this. Okay, I'm starting to remember this a little bit now. We create a new string, and it's actually asking standard in for the next line. Oh, okay. So basically, they're calling my code and handing it a line into standard in. And that's how they're passing data in. So it's not that they're like running functions or something. They're literally compiling and running the binary over and over and over again, which is pretty cool. The real Enrico, hello. How are you doing today? Look at how Dual Owl persuades people to keep at it. Didn't they just change recently? I vaguely remember, I've never used Duolingo, but I've heard that they changed the owl a little bit. Okay, so basically it gets entered in. So here's that input line. Okay, that's parse input. So we get a vec of stirs. Here's the parse input. So we can get X and Y. Well, look at that. They have Rust Analyzer working for us. We can actually see everything working in here. That's really cool. They did not have that the first time I took a look at this. That is so much nice. This is just VS Code in the browser. That's not bad. So we have our current X and Y, which I'm guessing is the center of each of our pod. Okay. And then parse input, inputs. So input 0. Okay, so input 0 is our X position. Input 1 is our Y. And then they give us the next checkpoint, X and Y. They give us the checkpoint distance and the angle, which it looks like they failed to finish writing this. So I assume that this is inputs 5, which is probably an F32, right? It should say in here somewhere. Okay, first line, 6 integers, X, Y. Oh, integers. So it is an I32. Oh no. The internet really had a field day with all the memes of it. Okay, hold on. Sorry about that, the real Enrico. I have unknown links turned off. What's funny though is that ReStreamBot just sent that along, so it's that was visible on YouTube. Okay, so we get you. So that gives us our next checkpoint angle. So we have everything that we need here. So write an action using print line message. Oh, so it's just print line to standard out of what we want to do. Oh, second line, 2 integers, opponent X and opponent Y for the opponent pod's position. Oh, interesting. Okay, so we can get our opponent's position if we really want to. So we get all of our position type stuff, and then we could get the opponent's position if we care about it. Let's wait to see if we can win without even caring about our opponent whatsoever. We're debugging the inputs, which is just all of these together, but we can really just put something like X, Y. Oh, we don't have autocomplete. Looks like we don't have autocomplete. That's too bad. Expert point X. Okay, so if I have that, now they want me to do I could do an ePrint line, or I wonder if debug will work. Let's test in Arena. Oh, no. Okay, I want to play my code. Okay. For some reason, I thought test in Arena was like test in a local arena. It's like, no, that's actually like submit it for playing. So what you're saying is that we can tunnel escape to YouTube from the tyranny of the auto mod bots, apparently, when it's working. All right. Oh, I got a standard error. So, okay. If there's an error, it just immediately I'm out. Okay, so I have standard error. I didn't. Thread main panicked. Okay, so here's my debug code. We panicked at index out of bounds. The length is 2, but the index is 2 on line 21. So this didn't work? Hold on, next checkpoint X. So 1, 2. Interesting. So went through the loop once, and it was fine with that. And then at the second loop through, it failed for some reason. I think that's what it was. But okay, so I want to. How do I steer? Spencer, hello. How are you doing today? Hope all is well. I was wondering if you have any courses in Rust you can check out or any recommendations. You have a lot of resources due to knowledge you love. And also, MetaMe, rating with a party of 14. I'll get right back. I'll get right to you, Spencer, in just a second. MetaMe, how's your stream? And Mumi, Jumali, hello. Jumala, hello. How are you doing today? I was good. Excellent. That's good to hear. Awesome. All right. So we are working on, we're playing a little bit of coding game today. We're doing one of the AI mad pod racing challenges. We currently just crash on the starting line, but that's really cool. Just a little review of the 12 languages you went through this month. Oh man, 12 languages? That's a lot. But congratulations too. That's pretty awesome. All right. Spencer, so you had a question about if I have any courses on Rust. Have I tried a long time ago? We're going to try a little bit today. We're definitely going to try some. I haven't done one with other people that I know before. I think I joined in on some of Coding Garden's Clash of Codes when CJ was playing around with them. But that's all. Like I don't think I even did many with Rust. Or at least I don't remember how much I did with it. It was a long time ago. But okay. Spencer, you had asked, okay, say, hey, hope all is well. I was wondering if you have any courses in Rust you can check out or any recommendations. So I have so my paid course is SQLX in Rust. So if you're interested in SQLX and connecting to a Postgres or MySQL database and using that inside of Rust, that's one course I have. That's the only paid course that I have. That's $5 US. For free courses on YouTube, I have, let's see, create an ECS library. I have, Introduction to Axum and Introduction to You, but those are all both outdated now, and so you have to pay very close attention to the either versions or sort of where things don't work, figure out what the new things are. And then I have one last one, which is deploy or a Rust blog, or deploy the Rust book essentially to DigitalOcean. So that's those are what I've got. All right, let's see if we can get through this one here, and then we can take a look at Clash of Code. Okay, so write an action. So the action is supposed to be what the gas is? Okay, output for one game turn. One line, 2 integers for the target coordinates of your pod. Oh, the target coordinates of your pod, followed by thrust, the thrust to give to your pod. Okay, so I want next checkpoint. So I could literally just say X and Y for the next checkpoint. So we could do something like this. So we want next checkpoint, X, next checkpoint Y, and then 100. We're just always doing 100. How about that? And we know that these exist. Let's turn you off. So let's try playing and see if we crash this time. Instantaneous crash. What happened? Timeout. The program did not provide one input lines in due time. Standard output, okay. Index out of bound. Okay, so this thing isn't working the way we sort of expected to. So if I comment you out. Oh, that's okay. So inputs. So I only got these two things, didn't I? Let's do that debug of inputs. No, I don't. Oh, do you have any web on practicing like gaming style? Unfortunately, like this is not really, not that I know of or can recommend. Well, I guess like Screeps maybe, but that's not really a website for it. Coding Game's REST templates for reading input are so weird. I'm not super happy with that. Okay, so my inputs, here's what I got. Okay, so I have two inputs. Oh, okay, hold on. I got input 1 and then another inputs again. Okay. So let opponents. This is important. So let opponents equals. Give me a new string there, and then we'll read line u. Now, if I don't do anything with you, at least then it's reading both of you. So maybe this will be fine. Okay, so I just have this one. That's fine. I am standard output stream. I guess I didn't do anything. So if I now do this one. Print line, go to next checkpoint X, next checkpoint Y at 100. Why are you upset? Oh, because I need you. Okay. Well, there we go. Okay, so I zoom towards number 1. Which one am I? I think I'm this tan smaller one. I think the larger one is the boss, and technically I'm losing. The first inputs are only given once before the game loop. It doesn't look like that. It looks like it gives me the first inputs every single time. Okay, so now the code works, but I'm losing. So what I'm thinking that I can do is slow down and stop moving forward once I'm closer to the what is it called? The finish, like each checkpoint. So we have the next checkpoint distance and then the angle. I'm not sure the angle matters too much, but if this distance is within a certain amount, I can just turn off or I can like slow down. So, oh, you know what? I need to check to see if it's behind me or in front of me. Okay, so hold on. We should take a look at these inputs and go through this again. So, angle is this one, and this is the distance. I'm trying to understand what that looks like. It's 0 a lot of the time. And I'm not sure what that is supposed to mean. Like -2 once I reach here. Oh, cool. I can step through. So here I'm at 1. So I'm at 1, 1, 1 because I'm guessing I'm straight at it. 4. 56, I'm right over it. Oh, because I hit it. So now it's looking at 2. So it's 57 degrees, so it's off by a little bit. Okay. 63, 59, 34. So, and then it goes to negative 95 because now it's on my left. Okay. So if the angle is small, I'm facing directly towards it. So if the angle is small, full distance, like full speed. And if the I guess I still don't understand like why I wouldn't just only use the checkpoint distance. So let's figure out what my speed is going to be. So let's set our speed to be 100. If our next checkpoint distance is less than, so this is a pretty large number. By the time we get to like here, it's like even at this point right here, it's 1069, 1800. So if it's less than 2000, then I probably want to set the speed to like halfway. Oh, don't worry about this, Tea Kettle. Let's go ahead. I'm okay with backseating if we're like figuring it out together. Like the way I think about it is that it's going to be like a pair programming session, right? Where we're all sort of trying to figure this out at the same time. I'm not very good at like strategy type things, but I love playing them even if I'm not very good at it. So to me, this is more of like, hey, this you can help me out here. So I think backseating is okay. I can actually add that in as a tag. Hold on. Backseat gaming. Backseating allowed. Okay. So if you're less than 2000, maybe we go to like speed equals like 50. Yeah, okay, so you're never red. That's fine. And then here you become speed. Cannot mute. Oh, mutate. Yeah, that's a thing. So let's see if I just slow down shortly before I get there, if that just makes me win automatically. Oh, I made the turn a little bit tighter, but I'm still behind the boss. And I still lose. I clearly am slowing down a lot more though. Okay, so perhaps instead of speed, maybe more gradual change in speed. Yeah, maybe something like that. I felt it was closer. What do you all think about if we check the angle though? And the bigger the angle, the slower I go. So like the farther you are away from 0, the slower it is. And we can almost do like a map. Like map an 0 angle to 100. Map a anything beyond that. So like oh, it's 180 to like 0. Is the Screeps game always up to date? Yes. It's like an online game, so like it kind of has to be, I think. I've only ever checked the Steam, like I got it from Steam, so it's up to date there. Or maybe I don't understand what you mean by up to date. Let's see. I can do pattern matching with match, right? So if I match this, can I do something like 0 is going to be 100 for greater than 0? I want 90 for greater than like 25, or maybe even like 10. I want like 75, something like that. Of course, like having this be some kind of like a normalization thing would be good, like an actual map as opposed to just manually doing it like this. But we can use this as a proof of concept. Will this work though? Let's see. And if it's above like 25, let's go to like 25, let's say. And if it's unknown, you're at 0. Can I do that? Expected nothing? Oh, because I'm returning this, yeah. Oh, okay. I was really hoping I could do like a pattern here and then match it based on that, but I think I have to do this with an if. So unless I'm wrong, can I do that kind of pattern matching in a match? I don't think I can, right? Oh, you can do if x. Oh, hold on. Let's try that. I don't think I've ever tried that before. So this would be, okay, so if it's 0, that's fine. This would be x if x. How would I do a range in this case? Oh, but I see how that works. Yeah. So if I do that, I'm thinking some combination of scaling factors, some offset. For example, speed is distance weight times distance divided by breakpoint distance plus the angular weight, which I don't think we have an angular weight yet. Or unless, like, do we have angular weight? I don't think we have something like that. Oh, like 1.10. Oh, let's try. Let's find out if this works. So here, if let's play this and see how this fares, and then we'll try Moomy's, yours, and then Tea Kettle Drone. Let's see if we can do yours too. I went to, oh, look what it does. Okay, so it slows down to almost nothing, and then as soon as it points at it, it goes to it turns on the gas, but that's not really what I wanted to do. I lose by a huge amount now. Yeah, I made it worse. The weights would be things you choose arbitrarily, like how much influence, distance, angular has over the rest. Okay, so when we did some game dev a long time ago, I remember with the vectors, so like you have your vector, right? You're like x, y, and then to like move in a direction, you can do like vector math, where like x plus x, x plus x, y plus y, something like that. We kind of want, it sounds like similar, like it feels like close to what you're talking about, Tea Kettle. I want to try this thing though. So like without changing anything else, can I do something like 110? Nightly, it's experimental. Okay, so good idea, Moomy, but it's experimental, so we couldn't do that. Can the angle be negative? Yes, it can be negative. Negative means that it's on its left. So it's, imagine we're in the car, it's to our left, so it's a negative angle. We have to turn to the left. Oh, we can do that. Okay. So yeah, this should work. So we could do 10, like, something like that. Oh, and I keep on adding that. I forgot that I have these. Okay, yeah, so this should work. You are multiple patterns. Here should be 11. Yes, this should be exactly the same result of us losing by almost like half a lap. Wait, I won? I think I only win because this map configuration is better for me. Or I changed like the values a little bit and didn't realize. Okay, so we won that one. Imizadrin, hello. Let's try yours, Tea Kettle Drone, though, because I think it's going to be better. So this is one option for us. Oh, it's going clockwise, no negative angles. That's true. I would want to match this. Oh, that's probably what it is. I would need to like absolute value it to get positive numbers, which I could do. I do like the scaling factors with some offset and sort of dynamically figure out what we want to do with the weight. So let's see. T. Kelly, you were thinking speed equals, okay, so the distance weight. So if we just have a distance weight, you're saying like just something we make up, right? So if we just have that be an arbitrarily 1 right now, we can play around with it. Times the distance divided by the breakpoint distance. Yeah, it would give a continuous range of thrust. So instead of like being, okay, at this point you cut down, it's like, okay, we're like 10 pixels closer, like, one little bit more thrust. I think I like that. We're going to find out, right? So we would have our distance divided by breakpoint distance. So, we need our breakpoint distance. So I think we decided it was going to be something like 2000. We have our angular weight. We can just arbitrarily set that to 1, 2. And that's going to be 1 minus, okay, absolute angle divided by 90. Okay, so then The thought of breakpoint distance is also some arbitrary distance you decide where to start breaking. Right. So we just sort of make it up at 2000 pixels, I think. And I think that's from the center of it. Then some kind of offsets, because I assume we don't want to go all the way to 0 thrust. So shrinking the range and finding offset. Oh yeah, that might be good too. Let's just try this and see what they're going to do. So we have our speed. I actually don't need this set there. Okay, so we have our distance weight. So we're going to multiply that by our distance divided by breakpoint distance. So how long we want to be divided by the little bit, so we get a little bit less of it. And then of course that number shrinks over time because the division as it's getting smaller. So that's why the speed sort of changes for us. So that's going to be our distance divided by our breakpoint distance. And then we add that. So these things are going to happen first because, you know, multiplication. Then we're going to add it with the angular weight. Now, right now we have the angular weight being 1. So we can change those, which will affect the entire thing dramatically more than some other number because it's a multiplication. Now we have 1 minus. Is the 1 minus because that way it reaches 0, because it would never be 0. It would always be 1. I think we have to divide the whole thing by the sum of the weights. So 2 in this case. Let's see what this is, because we can just debug this out and sort of see what we have in each sort of go through it. Okay, so distance, breakpoint distance, angular weight, 1 minus, we have our angle, which is the next checkpoint angle dot absolute value, and then we divide that by 90. So this happens first, and then we subtract by 1. Expected function found integer. Oh, because your multiplication, missed that. Distance. Cannot find value distance because you're supposed to be checkpoint distance. Okay. Let us so we can now take a look at our, oh, here. If I bring this debug of U down here like that, we'll now have just our debug of speeds like U. That screwed up all of you. That's cool. That's not what I want. Oh, come on. Undo. Oh, gross. Where did that other angle go? Right there. How do I... No, that's not it. I can't undo that. That's unfortunate. Oh, wait, I can select multiple and do shift. I was doing helix commands for that. That didn't work. Haven't thought about what's going to happen when checkpoint is behind us. When checkpoint is behind, yeah, well, yeah, and that does happen, doesn't it? let's find out. Let's see what happens. So we're a little bit slow on the gas. We're currently speed 4 out of 100. Who let grandma drive? It's like, hey, you want to go to a race? It's like, no, we're going to speed limit. The speed limit is 25 miles per hour. The speed limit is 4 pixels per frame. Come on. You know that. Okay, so we need to scale up the max thrust. We need to scale up by max thrust. Yes. So we have let max thrust 100. So I need to multiply this by max thrust, right? So let speed equals that. So let's do this entire thing and multiply by max thrust. And not plus, multiply by max thrust. Sort of like one odd thing here is we're working with I-32s and not F-32s. So we're not really getting good, like it's not going to be a number between 0 and 1, which I'm used to with this type of thing. They're not floating point. So we're working with like 1, 2, 3, 4, that something like that. So I should clamp it. Now, does this mean that I'm just always going to be 100 speed? I'm curious about that. Can we get into F-32 land? Absolutely. I can convert everything to an F-32 and then everything back into an I-32. Yeah, our speed is always 100 now. Is that true? Yes, our speed is never changing. How are we winning? Oh, we're not winning anymore. Yeah, we're okay. So yeah, okay. So we need to get into F-32 land. So I can parse input here as F-32s. They come in as F-32s. So that'll be something like, 500.0 to begin with. But once they're F-32s, these all need to be dot zeros. Then we do this entire thing. Why are you upset? Cannot divide I-32. Okay, next checkpoint distance is still an I-32. Wait, didn't I? Oh, it only did one of them? Oh, I can't. I was doing .d thinking that I was selecting them all like a multi. Oh, okay. Multi-cursor, but that's not what I was doing at all. Okay. So then if we do that, then if I clamp you to 0.0 and 100.0, and then I think we're okay unless this absolutely cannot handle an F-32. So let's find out. Cannot divide. Oh, I still have a problem here. Oh. I still had a problem there. Okay. Now our speed is still 100.0. I'm not seeing it change. So the algorithm is not working. Oh, invalid input. Expected XY power, but found that. Okay, okay. So I need to convert you. Okay, so speed. Okay, so after I clamp you down, I need to then change you into an as I32. This should be safe because anything between 0 and 100, I shouldn't like lose anything weird. Bring the max thrust to the front for readability. What do you mean? Oh, like max thrust? Oh, up here. Yeah. Got it. I can apparently make this larger. Our speed is never changing, so it's always above 100. I'm curious if I don't clamp this down. Okay, let's debug this. What numbers are we working about? I'm guessing it's like a really huge number. Oh yeah, look at my speed. It's like 300. So this is working correctly. Let's not multiply by max thrust. So I'm going to bring this to 1.0. I just want to see what that looks like. Right, it starts too slow. Right, we're back to the speed 2. Speed 1. Speed 2. Okay. That's good. The better Owen, hello. How are you doing today? We do also need to scale down speed by 1 divided by angular weight plus the distance weight. Okay, so it can't just be a... So we have to scale up by max thrust, but descale... Don't we just need... We need to normalize this. Oh, look at that. Okay, so wait. Our speed is 1 point something when I don't do anything. What I really want to do is divide by... Wouldn't I want to just divide by 10 and to normalize it? I guess, like, how do I normalize something? I can... I forget how to normalize something to make it like a number between 0 and 1. That's not a normal thing I can pull in, right? That's like not on a number, so I can't do like I can't do something like speed dot normalize. That'd be really cool if I could, but I don't think that's a thing. Okay, so scale down speed by 1 divided by angular weight plus the distance weight. Oh, okay. So 1 over that. So speed. The last thing you're saying is that the next checkpoint distance over braking should have a min 1. In theory, we shouldn't ever need that last clamp thing. Yeah. I put that in there for safety's sake. But we don't need to keep it in here. So let's try. Okay, we have this will be our raw speed. So we have a raw speed. And then I want to scale it down. So then we have our speed equals, this will be our raw speed. We can still multiply it by that, right? Tea kettle, and then because that number is going to be small enough, it should reduce it down. It's not going to be a number above 1. It should be a number below 1, below, between 0 and 1. So it should be our raw speed times, and then this is going to be the 1 divided by the, okay, so our angular weight, so that's going to be, yeah, angular weight divided by distance weight. And then we have our inputs and speed there. Yeah, raw speed should be like an input that's something like 0 to 1, and then that gets scaled up. Okay, so we'll see what raw speed is. Oh wait, we already know what raw speed is. It's oh, so this is now, let's do that. This is now normalized speed. And then we will multiply this by max thrust. I wanted to do this with the other lets here. Let our, then it's our speed equals the normalized speed times 100. No, times max thrust. Why are you an output? Because you need to be 1.0. Ah, that's why. That's why. Okay. So I don't see any red. Yeah, that typo is because it was apparently a crash and the compiler knew that it was going to be a crash. But instead of telling us, hey, it's a crash, it just told me that that's what the output it was, which is weird, but a thing. Okay. So then we finally have debug inputs and speed here. So I don't think we need this debug. We can move and say that you are now speed is speed. Let's see how this feels. Instant crash. Oh, because, okay, the speed needs to be an I32, which we can do this here. So speed equals that as I32. Invalid input expected. Okay, the power to be between 0 and 100, but our speed was 525. So if we take a look, we have our raw speed is 5. Our normalized speed was literally the exact same thing. Oh, I don't think I did. Min, where did the min go? The min... The last thing I'm seeing is the next checkpoint distance divided by braking should have a next checkpoint distance, breakpoint distance. Yeah, this should have, okay, so a min of 1. See how that likes. Okay, now our raw speed is 2. Do I need to make that 2.0? The normalized speed scaling factor is incorrect. So normalized speed, okay, so raw speed, so that's gonna be 100 is our, no, raw speed is whatever this is. So raw speed is 2.0. Should be weight A plus weight B. So angular weight, wait, did I do divide? Was it supposed to be add? Oh yeah. Why did I do divide? Okay, so our speed does go down. It doesn't go down by enough, so we can now play with the weights, I bet, to make that hit where we want to a little bit more. However, we're doing a lot better. Yeah, okay, so let's take our weight. So our distance weight, if I increase this, if we increase the distance weight, that makes it a higher raw speed or a lower raw speed. It's going to be, okay, minimum 1.0, so it's going to be a higher raw speed. I actually want this to be a lower weight. So I probably want to put this down to, like, let's do the binary game. So if I just change that one number and play with this, then we should see a difference. I like to, when this type of thing is only make one change at a time and just see how that affects it. So that way I know what one thing did. Okay, better. I feel like it could be lower still. Like that's giving this trial boss a little bit still making it too easy for them. Wait, I set that to 5. I meant to set that to 0.5. Oh, I found I got a -6 on my speed. Oh. So I need a clamp. I do need this clamp to make sure I stay inside of 1 and 100. Yeah, the angle was behind us, yeah. And it tried to slow down, it tried to reverse to get close to it. And that's not what I wanted. Now, okay, this is a lot better. I'm now like, I want to slow down a little bit more. And so either my braking distance we could reduce or further reduce our this weight. I feel like I'm okay with the braking distance being like this direction. I almost want to go down to like 0.2. I feel like I should be able to like get to the point where it hits it, so it's way down and back up full again. So it doesn't really go past the checkpoint very much. But maybe the braking distance is too. Maybe I need to set that higher. But I'm winning by a lot more even. So let's add this to like, I don't know, 10,000. And let's see if this is too slow. And then after this, I think we can clean up, remove a bunch of the debugs, and test an arena and see how we do. Yeah, so I'm hitting that one, and then I'm basically making a very tight turn, which is very good. So that's good. Not really sure why reducing that weight so much is working, to be honest, but cool. Yeah, I've never really learned the weights type thing when I was doing game dev. But it's fun to play around and sort of see what changes. My understanding about the weights is that they indicate how much influence from each factor we're taking from each. So a large distance means we care a lot about the influence of distance. Okay. So maybe, yeah, I think what we're doing is we're breaking early. So I think I was doing 1,000 before. Oh, no, I was doing 2,000. Let's do 5,000. And then let's just send this and test in an arena and see how we do against human bots. Sure, we'll test it, make sure it works. But I'm fairly sure we're going to win. Oh, we're going to win by a lot. Okay, we're good. Testing the arena. Oh, is this the match? Here we go. Why is it just failing all the time? Is it me? Oh, it was other players were crashing. They submitted bots that were crashing. That's what was happening. Okay. Here we go. We are this one right here. And our the red is our opponent. We're in first place. I guess the first league has lots of completely failing solutions. I'm surprised that it allowed it to submit with those failures. Okay, we won enough that we apparently made it to the next league. You now have access to boost to give you an extra edge during the race. Once per race, you may substitute your desired thrust with the keyword boost to grant your pod a burst of speed. I know that is not cool. Okay, so we are in. Okay, so we were in Wood League 2. Now we're in Wood League 1. So that's really cool. So um this is coding game. This is what allows you to do it. You could do it in any of the languages that they have here, which is a lot of them. Yeah, this is really cool. I like it. It's a little bit odd the way they have this set up. I think that what I might do is switch this around to be like a struct and like pull in the struct and we just copy and paste that in. But like it kind of works the way it is. It's just really ugly and it's just all super procedural, not great. Which league introduces weapons to blow up your opponents? Now that is pod racing. I don't know, and maybe it actually will. I do remember that I saw in like one of the previews that like there were some pods that were literally fighting against you by pushing you out of the way and being defensive. So like maybe that's a thing. But okay, this is pretty cool. So now we're gonna use a boost once, which does not say what that means. You just made it a bronze league and it says there's now collisions. Oh, okay. So, oh, in the next league. So once I finish this one, then we go into collisions and we do that. Okay, that could be fun. All right. It is 4 o'clock. We got half an hour left. Let's we'll come back to this tomorrow. What I want to try is a little bit of the coding. I want to try Clash of Code because it has been a long time since I've tried this. Andrew, hello. How are you doing today? Or how are you doing? I think, were you here this morning? Great. I've reached level 8, apparently. So what was this? First steps. So solve 2 clashes. Then do them in less than 3 minutes. Okay, apparently I did all this sometime in the past. Win 2 clashes. Okay, so I won. Now I need to just play 50 clashes. Okay, so let's see what this is. Clash of Code is by far your favorite thing in coding game. You love seeing everyone else's code after each round. I vaguely remember this, and I don't really remember what happens or like how it works. So we are going to we're just going to jump in it and see what happens. Oh, and we can do a private clash too. Let's do one public clash, and then we could try some private clashes and see how that works. Oh, and you can join in on a clash too. Here, if any of you want to join in, if we have time. There is the link to this specific clash. You got to sign up still? Yeah, we probably don't have time for that. Not for this clash. Andrew, is that you? Oh, nice. You're stream snapping. I don't really think it matters in this case. All right, 40 seconds. Yeah, it seems like it. It'll be fun. So I have not I am not like a pressure coder. I've never really been super great at like, oh, super fast coding. And I think you got like 5 minutes to do this. So it's gonna be interesting. We'll see. You have to pass a maximum number of tests as fast as possible. Oh, great. Okay. Well, first of all, let's just standard. Okay, so input, full register, output. It usually takes me a long time just to understand what the heck I'm supposed to be doing. You have to extract the value of a custom sized bit vector contained in a 32 bits register. This value is an unsigned integer. If you have the register value 9, the start bit index 1, and the last bit index 4, you have to get the unsigned value between the second and the fifth bit. Wait, so is it less than, or is it what's the thing where I read the previous bit? So it wants expected 1, and I literally had just a question mark. Okay, so I have register. So the full register value, index of the first bit of the bit vector to extract, index the last bit of the bit vector to extract. You have to extract the value of a custom. Okay, I'm going to spend my entire time just understanding what they want. If you have the register value 9, the start bit index 1, and the last bit index 4, you have to get the unsigned value between between this one and this one? So output that equals 4. How would I do this in Rust? I get the actual number, right? So A, B, C. Okay, yeah, so I get 2, 1, 1. So I have 2 is the register value, the start bit index of 1, and the last bit index of 1. So in this case, I expect 1 out of here because 2 would be 0, 1. So this is a 1 and everything else is zeros. I want 1 here and 1 here to here. Or is it here to here with this being the 1? Zero, 0 with, okay, hold on. What is this? So if we take a look at that, oh, I didn't need to do all of them. Oh, it doesn't like that at all. So that doesn't work. Okay, so I can't get access to this. Oh, I need to be like a B. Oh, not that character. That character. Maybe. Oh, those are the bits to extract from the example. Yeah, but how do I get access to that? Because I could do something like what is it, like A, B? But I don't think that will give me what I want, right? Oh, that gives me no. Oh, Andrew, I can't read that. I, yeah, that would make it hard. It's you bit shift first. Yeah, I forget how to bit shift in Rust. It's how do I bit shift left? It's not. I thought it was the less than character for something though. But is it like that? Just strings in Python? Oh, right, it's that. Oh, okay, so hold on. If I do A is the first one, and I bit shift left by B to get, that gives me 4. Because 2 is the number here. No, that's not right. Yes, this should shift left by... Oh, this shifts left by 1. Okay, and what's the shift left by 2 or by C, which is, well, that's gonna be 1 also. Do I want to take like the 2 and like do that? So I had to have like A bit shift like that by B. I don't think it's anything like this, right? This doesn't make any sense to me. Oh, I would need to like print line this out. I can't imagine that this, like, that will work for... Oh no, that got me 4. Wait, isn't 4 4? So there's 2 1 1 4. Oh. Yeah, 4. Okay, so wait a second. You're also 4, right? That's 4. That's 4. Isn't 4 divided by 4 1? I want right shift, not... Oh, right shift. Hold on, what's right shift be? That gives me 1. And C... Okay, well, they're the same thing, so that makes sense. But I can't... Like, if I do something like this, and we just do result. Like, okay, that works with this test case. But you found 32 and expected 0. C, 32 equal again. I want the between them, the amounts between them. I guess, like, I still don't remember. I don't know my bit vector math for this. Oh, we should and to cut off the left side? Ugh. Okay, so it's and first, right? No, it's and second. No, doesn't like that either. Oh, it thinks that's a borrow. Ups with 1 bit shift left to be -1. Why are we bit shifting left? Do we bit shift left by... And inside, So we want to get the unsigned value between the second and the fifth bit in this specific case because you're passing in. I guess I wish that this example was equal to this thing here. So it is 59. So this is, we start with 9. We bit shift left by, this is 4 times. And then I want to continue looking until it's not a 0. Do I have to, I have to loop through between the two and like continue to subtract through this until I hit the one I want. So, okay, 1. Oh wait, do I have this backwards? Is it supposed to be the number I'm bit shifting by first? So 1 bit shift left by B minus 1 gives you number with B of 1. For B equals 3, it's 1 bit shift left to 3 equals 1000. 1000 minus 1 is 111. It's supposed to be a, you could do the shift first too, but the bit mask would look different. Oh, so I have this backwards, don't I? So I was thinking initially of like shift left by the amount they want to get. But this, I don't think this matters either, right? So like, yeah, okay, so we get 0 is because it's a 0 here. And if we do that as like a minus 1, no. I know, 3, how is it only 3 minutes? Oh, I thought they were 5 minutes of these. I guess they're 10 minutes long. Yeah, the problem is like I still in my brain having trouble like visualizing how this works. Like I want to figure out how to solve this in my brain first. And then I feel like I'm still just sort of trying random things because I'm having trouble, like my brain isn't wrapping around this problem. This is usually what I mean by like I have trouble with these algorithms, like when there's time pressures. So what I want is like for this first one they hand us 2, 1, and 1. So 2 would be, 2 is what? A bunch of zeros with 1 and 0, right? So that's 2. And then the result that I'm supposed to be getting is 1, right? So is 1. The reason why I get that result is because you have to extract the value of a custom bit vector contained. Oh, okay. So we start there and I say I want from 1 to 1. Now 1 to 1 is, oh, does it start with 0? Oh, because it starts with 0. This is it. It's just that. I'm just going from here to here. And then that means I have a new number, which is like that. That's the number I have. Essentially a binary number of 1. And a binary number of 1 is 1. That's the answer. That's how we get it. So if it was this 9, Okay, I got it. Yeah, sure. I figured out what the problem was by the 10 minutes. And that's all I got. Andrew, you used Python. Nice. I love the sort of the grouping of languages. We have like Ruby, we have Python, PHP. Nice. I don't know why I can't see your code. It made me show my code. But cool. All right. He had to use Ruby for this. It's too perfect. Was Ruby able to do something really cool for you? Let's try doing something a little bit more private. What type of clash? Let's not do fastest. I don't think the fast ones are that interesting. What do you think? Should we do fastest? I mean, I'm okay with adding it in there. All languages are okay. In Ruby, integers have indexing operators defined such that A, B, C just takes the bits from bit to C. I wonder if Rust has that. It might, but that's a cool feature. That definitely makes it a lot easier. Okay, let's try just like a full clash. We'll do private. We can do a whole bunch of people with this. Here is the link if you want to join it. I don't know how many, let's see, we have one concurrent viewer on YouTube, which I don't know how accurate that is. And we have 15 of us on Twitch. So I don't know if this might be it. Let's go ahead and start this. And if you're interested in playing, send a message in chat, and I'll leave it as a longer time next time. But let's go ahead and launch it. Fastest, okay. If you read the book or watch the movie Fight Club, you know about the narrator and Tyler Durden. Even if didn't, don't worry, because this puzzle is easy to understand. When narrator snaps his finger, he stops talking and Tyler starts. When Tyler snaps his finger, he stops talking, narrator starts. You give him a conversation with narrator and Tyler. When the snapper opens a snap, you just find out who talks last. Okay, so a string conversation. Can I just see what this looks like? Debug of conversation. Okay, so I want every, oh wait, there's no, Tyler already starts, right? If the last one was narrator, Tyler, if the last one was Tyler, if you're given, has no saps. Print narrator if the last one was narrator. Tyler if the last one, wait, how do I know which one started? Narrator begins and a snap is represented as snap. Oh, there it is, one snap. So it starts as narrator. Okay. So if I do, oh, it's possible to join mid clash. Oh, that's cool. Excellent. So let's see, we can have an enum. I want like an infinite like loop to go around, don't I? Or I could, so this is not good for speed, but I could do an enum speakers. We could have Tyler narrator, and I can do like +1 and whatever the +1. So impl, what is it? Add for speakers. Oh wait, no. How do I want the thing that auto adds in the impl for me. I don't actually remember what add is. Is it not add? Ooh, I don't know how to do this. What I was hoping is I can impl add for it and I could just do plus, and then that would just work. But I don't remember how to do that. We could do impl. We'll just manually do it. Add. Use an infinite iterator and get nth count. Oh, that's a good idea. I forget how to implement an iterator, like off the top of my head without it implementing the thing. But that would work, right? Well, no, then I don't even need to do that. If it's every other, oh, it's a modulus problem. It's a modulus problem. We start with 0 or we start with 1. And we just add, we'll probably get an off by 1. So we'll just do let mute snaps. Start with that. And then we loop through it. So we break, we trim matches. Okay, so we have the conversation. So I want to let words. Oh, I just want to count the words, right? So let, can I count how many snaps there are? Oh, can I get an iter? I want to find. Ooh, wait, no, I had to split by split by snap. Split by snap, and then I want a count. So that gives me the number of snaps, and then I divide. So I want to modulate by 2 if it's Tyler. Otherwise, it's let speaker equals if snaps modulus 2 equals 0. So then it's what is it supposed to be? Narrator. I'm either backwards on this or not. So that's wrong, but that's because I got an error. Speaker, I need to finish that. That is opposites. Let's do the other way around. Oh, none, because there's a none. If there's if count. Okay, so if snaps, so really I want to do if snaps is 0, let's do an early return. So we're gonna just print line none of them and return. What? If snaps 0, oh, I can't. Okay, conversation was I am Jack smirking revenge. And I put narrator out instead again? What was snaps? Oh, snaps is 1. Because your count is 0? Strange. Okay, snaps equals 1. Submit. 100% score, yes! All right. Oh, right, I always get at least 1 because I'm splitting. Oh, I forgot about that. I'm counting the things after the split. After the split. Oh, I forgot that. That's what happens when I don't solve the problem in my head first, like fully solve it and like write down the solutions and then like line by line go through it. All right, while we're waiting for Chris, let's take a look at the code. So we have Andriama Nitra. You're using Rust. Okay, so we have our conversation. We read that in. So we have, okay, so you're doing a split too. And then you're doing the same count. And then you're just doing an if, else if. So if it's 1, none of them, otherwise 2 modulus. Okay, 1, narrator. So, okay, awesome. So that's like very similar to the one I did. Andrew, you did. Okay, then we have 2 Pythons. So Polynomu. Python 3. Okay. So, oh, this is so much easier. You just count. Okay, so you did c.count the number of snaps in them, and then okay, so if it's 0, you print none of them, you exit out. Otherwise, that's this type of stuff is like the fun thing that you could do inside of Python. It's great. Andrew, you also used Python. Okay, this is a lot closer to like the one we see in Rust as well. You can do that in Rust too? Oh, I don't know that trick. Right answer. Okay, so basically you did the exact same thing. So you count through that, except you just use if statements. So awesome. Good job. And then finally, Chris. Oh, but we can't see the language. But you use Haskell. Good job. I know, I wish we could see it, but we can't. I know, but Haskell is awesome. So, good job. It is 4:30. We can try one more. So let's do a play again. We can try one more, and then we'll have to end it for today. So here is the link to this this clash. Oh, Tea Kettle, that was you? Okay, awesome. Yeah, no problem whatsoever. But that's also awesome that you use Haskell for it. You could try to solve yours in Haskell, but you've not used it for a year already. I wish I wish that they would give you maybe like if you're trying to do it in a new language, maybe you can have like more time. Like maybe you can have like 20 minutes or so, half an hour to like try to solve it. But I guess that's what the other sort of like challenges are for, aren't they? All right. Let us, okay, so we got everybody we got from last time. Let's go ahead and give this one. You want to start in Ouya? I've never heard of that language. Let's go ahead and get started. Fastest mode again. Random number generator. You did not help me. Okay, you need to create a list that is sorted from the inside out, from the least to the greatest. Okay, create a list that is sorted from the inside out. You take in an integer n for the number of integers in the unordered list numbers. The unordered list nums, which contains n space such integers, output a sorted list from the inside out of numbers. Wait, how does that? So, okay, we take in. Okay, it tells how many numbers there are. So that's input line. So n, and then. Okay, so if I nums, that's. So 1, 2, 3. Okay, so it's giving me. It's okay. I like this one. The first one is actually what they have here. So they give me 1, 2, 3. Oh, okay. So input split white space. Where's inputs? Inputs is this one. And then an integer n for the number of integers in an unordered list. Okay, the unordered list of numbers. A sorted list from the inside out of nums. What does inside out mean? Constraint. Okay, so we know it's within 1,000. Oh, here it is. Visualize the construction as follows. Write down the smallest number. That first one is not the smallest number. The next bigger number is written on the right. Oh, the next bigger number is written on the left of the smallest number. Okay, so I need to first. So I have input strings. I get these parse inputs. Let's create. We'll push those into there. So now we have a list of the numbers, right? So after you, now I have 1, 2, 3, right? Perfect. So now we can write down the smallest number. The next biggest number is written on the right. The next biggest number is written on the left of the smallest number. The next biggest number, so we do smallest number in the middle. So it's almost like I need to pull. And the next biggest. Oh, so oh, there's a pop. What's pop again? Is pop from the pop is from the end, right? And then is there a unshift? Well, I know that the smallest. Okay, so smallest equals remove 0. Okay, and that gives me that. So that's the smallest number. Next biggest number is written on the right, so this is going to be our result, right? Result. So we're going to have a vector of that. Numbers remove 0. Why are you upset? Are removed value numbers. Oh, why are you... Oh, yeah, you're okay. Okay. Then I just loop through here for just for something. So in for each one of these, I put it on the next biggest. Oh, I want it in reverse order, right? So can I do iter alias reverse? So can I now do this? Just put it on the next biggest number on the right. So that would be result dot push n. And then I also want on the left. So result dot unshift. What's insert. Index element. Oh, but no, I want the next one, don't I? Oh, that does the exact same one. I don't want that. I want to like do every other one, don't I? And it's like, okay, I get this one, I get the next one, and I do that. That's like my initial thought was doing that, but this won't work because I'm going to grab the same one. I want like n plus 1. So I want enumerate. So we do that, and then I want to do this with n plus 1. And then I need to make sure we stop. So if, oh, n index plus 1. If index is greater than the numbers dot length minus 1, minus 2 really, then we want to break. So if I do that, then I want to print line. I want to join these together, I think. So we'll do result, join, space. It exists for vec of I32, but its trait bonds were not satisfied. The following trait bounds were not satisfied. I32. Wait, why do you not? Oh, because you need to be strings. Oh, okay. Hold on. Yeah, I need to map this. Okay, hold on. I need to map it first. So I need to let string result. So we can just shadow this, right? So result equals result dot iter dot map to string that collect into a vec of I32 Oh, nope, no. Yeah, now you're strings. Okay, so we collect you into that. Now I join you based on this. Doesn't implement display. Oh. I don't know where I got that extra dot. Let's try this. All. Okay, found 313. Wait, what do I have in here? Okay, so I have... Oh, I have 1, 2, and 3. Because I popped... I remove... Okay. I want there. So I start with 1, 2, and 3, okay? So I remove the first one. That gives me a 1. So there's my 1 right there. And then I get... index and end, so I push 3 onto it, and then I insert at 0 numbers of index plus 1s. That would be the next one. So if I start with the first one, so that's 2. Oh, and then I overwrote it? Wait, that doesn't seem to make any sense. What do I have here? So we have the n. So I have 3 and then 2. Okay, so the first one is 3, so I push 3 in, and then I attempt to insert 2 in to 0. Oh, I get it backwards. I want insert... I want to insert numbers of index plus 1 and n. No? Maybe. No, literally the exact same answers. That's not working. Oh, did I break out too early here? I want to break out at the end, don't I? Oh, out of bounds. Probably want to do this at the beginning, and then I want to do this as -1. Found nothing. Index out of bounds, the length is 2. Okay, I don't think I like... My idea for this is not working. I have vec dequeue and rest. Oh, wait. Oh, I keep... So the problem is, like, I don't use vecs that much, so I don't remember that I have something like that. So vec dequeue would probably be better. I can dequeue in like the appropriate one, right? So what can I do? So vec, what is that? Oh, it's a type of vec, isn't it? Oh, I think we used it once. I think I used it once before. It's not giving me any type hints here, so I don't think I have a vec dequeue like that. Solaris, hello. It seems to me that you add approximately 2 length of list elements to your result, but I don't know Rust very well. It's giving 3 in both locations, to the left and right of it, which is not what I want. Okay, so I have numbers for that. Numbers. Okay, so we push those in. I don't know what I can get. Yeah, for each step, I was trying to insert like the one to the left and one to the right, but that's clearly not the right way to do this. Oh, I was also reversing it, which is interesting. Oh, timeout. Sure. And there are approximately length list steps, right? Yes. Yes. Did anybody Oh, nobody did it with Rust. Oh. So at the end, the result may be too big. Maybe. We never get past the first one. So we had 313 when it was supposed to be 312. Oh no, did it do that again where it didn't go? Jay, hello. Come to the conclusion that Rust has a minimum IQ requirement and you don't have it. Oh, this type of thing with Rust is a lot harder. Like, it's not really meant to solve these type of problems like super, like you're also trying to solve it within a 10-minute time period, or a 15-minute time period, I guess. And that's not a way to like learn Rust. That's a way to like test to see how good you are at like math and figuring out like, oh, what things about like the library do you know without having to look them up? Because like I bet, oh, you didn't solve it? Okay, well, I feel better then. Let's take a look through what we have here. We also have Haskell. So we'll do the two Pythons first. Okay, so we start with creating an array. We get, oh, this is the auto-generated code. Okay, so we throw it. They put the stuff into an array for you. That's nice. Write the answer using print. Okay, to debug, print. Okay, so we do that. So you have length. Okay, so you have your answer here. 4. Okay, so we do the enumerate, sorted x. If modulus 2, you're adding that. So you have your element, so your index. I vaguely remember this. So you're basically just, this is appending. Is this appending to the end of it? I think that's where like adding it into the end of the array of the element. So it'd be like 3, 1, 2, something like that. Otherwise, you add in the element. Oh, the element of E plus that. Oh, it's the appendee. Okay. Got it. Yeah, I've never done code golf. I'm not very good at code golf either. Usually my way to do code golf is just write JavaScript and remove all the spaces. That's not a good way of doing it. Okay, that's pretty cool. Let's look at the other Python. Okay, this is easier to read if you're not into Python. So okay, so you're using a DQ. So we loop through the numbers. If modulus 2, I guess, okay, so modulus 2, I wasn't thinking about modulus. How does modulus 2 help us know that it's the next largest number? Oh, but you sorted it. Oh, if index modulus 2. Oh, I got it. Okay. I kept on thinking it was the element. It's the item modulus 2, but no, it's the index modulus 2. So, okay, that makes more sense. I didn't think about that. This is one thing about like challenges that like if it just takes practice to get into the mindset to like see these as possible solutions really, really, really fast. And I don't have that kind of practice, but I would love to get that kind of practice. But that's really all it is practice to sort of like, oh, look, we could do modulus on the index. And now hopefully next time I can remember that. And then you either append or insert at the beginning. Cool. Let's take a look at the Haskell implementation. So I've never used Haskell. Okay, so inside out. So this is the equivalent of a anonymous function, right? Or a function. So you're going to take in an int and return an int, an array of ints. So inside out goes at, okay, so this is a loop, right? So we're looping through XS. So we're creating an X and an XS. Like these are two different variables. Go is a recursive function, essentially a Haskell version of looping. Okay. Go left, right, reverse left plus right. Okay. Left, right. This is breaking my brain. This is like, I'm like, it's breaking my brain because it's like, this is familiar, but also very much not familiar at the same exact time. The first definition is the end condition. List is empty. Oh, okay. So we want go from whatever we have in here to an empty list. Okay. So go left, right. So go loop from left to right to do that. Okay, okay. Interact, unwords, map show, inside out, reverse sort, map read, tail words. That is functional programming of like that's that chaining. And these are all just methods that you get with Haskell, right? So it just does the thing that you want to do. And then of course, inside out is your function that you just stuff in there in the middle of it. Nice. The dot is actually function composition operator. Wait, so that's not like dot operators where you're like just taking the output of one thing and like running it as the input of the next? That's how I read it in my mind, but that must not be it. Interact unwords. I don't see those defined anywhere. So are those part of data list? Nope. F.g is like defining a lambda x. Okay, so you take in x. So you take in unwords. Oh, and then you have like, oh, interesting. Interact is part of the prelude. Oh, okay. So there's a combination of like library stuff going on, and then also just unfamiliar usage of dot. Interesting. Okay. Read it from right to left. Oh, okay. Because of how function composition works. Okay. Right to left. So words, tail. Is it map read or read map? So we're going to map through after tailing the words. So does tail get the last word? It's like it loops through and do that. Is there a way to access task? I don't think so. Take everything except, oh, tail. Take everything except the first element in the list. Just ignoring the first number. That was the number of elements. Oh, right. That was the first thing they gave us. I just sort of ignored it because they gave me that as part of the boiler print. The boiler code, the boiler something. Okay, so take everything in the list, get everything except the first one, read, map. Okay, so loop through it, sort it. So 1, 2, 3, 4, reverse it 3, 2, 1, inside out, then run this thing. So then we're going to loop through it, and we're going to return a new array. Where we're either stuffing in to the left or the right, depending upon what it is. Okay. And then show it. And it's not words. Map read is like casting the string into int. Oh, so like cast it into a number. Okay, so we're casting into a number, and then map show is casting it into back the string. Something. Unwords is the opposite of words, so join with spaces. that is a choice. I like it. It's so like something that I wouldn't have ever thought, and it's such a fun word to say too. Unword. This is pretty cool. As I said, also breaking my brain, but pretty cool at the same time. Awesome. Well, as I sort of mentioned this morning and this afternoon, while we are doing, while we're waiting for Axum and some other things to happen, we're doing some fun stuff. So tomorrow morning, we're going to be working on Axum. We're going to build out a really quick small thing with Axum 0.7. I don't know how many streams it's going to take. It might be a couple streams. It might be one stream. We sort of have to plan out what it's going to be, and then we just build it. And then I'm not going to do any like videos or something else. It's just like a project. Like essentially we're working on a little mini project. And then in the afternoons, we're doing fun stuff like this. So we'll probably continue with Clash of Code. We could just do an entire 2 hours of like clashes. But I kind of also like that AI thing that we're working on too. That looks fun. I'm not sure if this is the correct solution to the problem, but it can show you the Ouya solution. Are you in... Andrew, are you in Discord? I think you're in Discord, right? It will keep, if you post it in there, it will keep the, you can do it like the triple backticks, or you can share a gist or, oh, you can share a gist, and we can go take a look at there. But like Twitch chat or YouTube chat is not going to do a very good job at displaying that. Also, my YouTube chat got covered up. Okay, I think we're good to go there. But it's going to be only like 10 characters. I've never even heard of Ouya. It's the weirdest sort of looking language that I've seen, the one where it's just like symbols and that's all, and like, you know, an entire big thing is like 10 characters, was J. I think it was something like J. And that language is basically, you know, like if you hated typing on a keyboard more than you hated, more than you wanted to understand and like read words in a programming language to be able to understand what was going on, then like that was for you. We is similar to that kind of language, except it has a formatter that turns readable names into those weird. Oh, so you can write, you write like normal looking code and then it converts it into unreadable weird characters, but that is like fun to then share with other people. That's interesting. Can it undo it then? Because like what happens if later on you want, or maybe that's just how you compile it. You compile it. So like your source code is actually in the, well, I don't know. A formatter that turns it in. So like basically if you come back to it after like half a year, how are you going to do? Is it just going to be a nightmare to like read through all the code? It's one of those things where like to me it feels really hard to like imagine like doing a real life thing in that. It's a whole separate mindset, you guess. Never managed to get into array programming. Yeah, I don't think I have either. Let's see. Andrew, are you able to share it? Oh, you're not sure solution is correct. Unfortunately, I'm going to need to drop off pretty soon. Do you think we can share it quickly right now? So we just take a look at it, even if it's not correct. That's okay. Oh no, but I can take a look at that. Oh, they have a share thing. Okay, hold on. I can get that link. Hey, 312. Okay, so the first one was good. Oh no, you got timed out for 600 seconds. What? I'm sorry about that, Andrew. Hold on. How can I undo that? Can I like untime out? Untime out. Okay, I untimed it out you. Sorry about that. Apparently Nightbot really didn't like ouya.org, but I can add that into my Nightbot whitelist, so it won't happen again. So links, options, allow, ouya.org. Okay. You should be able to type again. And you should actually be able to share the same thing. But if you want to take a look at it, nope, that's not. This is the URL if you want to take a look at this same exact solution here. A stack-based array programming language. Okay, you also need to add it so it rotates array if it's even length. Interesting, okay. So lots of things that it's doing. It is a, so this is the solution. That is that is a fun language to share. I can't imagine programming in that. Like I think literally I would forget what I was doing in the middle of it. But it is super fun to look at. This is awesome. Thank you, Andrew, for trying this out. All right, everybody. I've got to head off for the night. Got to go grab dinner. Those are shapes on a screen. They are indeed. Oh, this one is correct. Let's take a look at that. Okay, so you added, look, I recognize a word in that. So cool. Yeah, put the largest one here, right? Oh, wait, is this the largest? No, one. Okay. Yeah, something is still off on it. I think it's supposed to be 3, 1, 2. Oh, bottom is the output. Yeah, it's supposed to be 3, 1, 2. So really close, but this is a fun language. All right, everybody, thank you so much for hanging out today. We'll be back tomorrow afternoon for more Clash of Code and sort of fun with that. I think we'll continue on with the AI coding because that was fun. And then if we have any time, we'll like finish that out with some clashes. And then tomorrow morning, we're working on a little project. We're going to make a little X Twitter clone with Axum. So with that, everybody have a great rest of your day, and I will see you next time. Bye. Sorry, Andrew, I've got to run, but maybe I'll check a look at this later. I don't know. It's intimidating. But anyways, have a good night, everybody. Thank you again, Andrew, for sharing this. This is awesome. And bye for real.